Welcome to Homework Lib.
To sketch energy diagrams for different situations. In the first one, we're going to have an exothermic reaction that is going to be thermodynamically favorable. And that is going to occur quickly. So remember, whenever we want to do this kind of diagrams, one thing is going to be the thermodynamics, which is going to be related to the delta G for the reaction, to say if something is spontaneous or not, and also to the delta H to say if it is exo or endothermic. Another part is going to be the kinetics. The kinetics are going to be given by the activation energy for the reaction that we're going to have. And depending if the barrier is higher or lower, the reaction can be quick or slow. So for this first case, an exothermic reaction that is going to occur quickly, let's say that this is going to be our reaction coordinate, and this is going to be our energy. The reagents, let's say that they start at a certain energy, then we're going to have a low activation barrier. And since the reaction is going to be exothermic, we're going to have a value over here that is going to be lower. For this to be thermodynamically favorable, what we know is that the delta G, remember that this is going to be delta H minus T times delta S. So if it is always going to be favorable, that means that delta H, since this is going to be exothermic, delta H is negative. So that means that delta S needs to be positive for this to be favorable at all temperatures. Now for diagram B, we're going to have also an exothermic reaction. So delta H lower than 0. It is also going to be thermodynamically favorable, but doesn't occur at a measurable rate. So in this case, the diagram, what is going to look like, energy with respect to the reaction coordinate. First of all, for this to be thermodynamically favorable, we know that delta S is going to be positive, it's going to be larger than 0. So this is going to make delta G lower than 0 for all temperatures. Now the energy diagram, let's begin with the reagents. Actually, let me put also the labels over here. Reagents, transition state, and products. We're going to do the same. But now what is going to happen is that the transition state is going to be so high in energy that it's going to become prohibitive, and the reaction is not going to occur. And finally, for C, what we're going to have is an endothermic reaction that is going to be thermodynamically favorable. And that would occur quickly. So for an endothermic reaction, what is going to happen is that delta H is larger than 0. So what needs to happen for delta G equal to delta H minus T delta S is that for a certain temperature, first of all, delta S needs to be positive, and this is going to be favorable only at In this case, we can relate at temperatures larger than this value. The value for delta H over delta S. For temperatures lower than that, the reaction is not going to be very favorable because we're going to have the delta G would be positive in that scenario. So, with this information out of the way, we can write down our diagram, energy versus reaction coordinate. This is going to be an endothermic reaction, so that means that in terms of delta H, it will look like this. And the reaction, actually, let me put them a little bit closer. Something like that. And the transition state, it would be not so high in energy. You can actually achieve this energy over here. Okay. So again, reagents, products, and the transition state. And with that, it would be all. Thank you very much and have a good one.